that this video will be challenging in a good way. I want to challenge the way that you think, challenge some of the ways that educational researchers think. And I want to start by saying philosophers in the 16th, 17th, 18th century debated a great deal about whether we could learn what a cause and what is an effect from observing events around us. If you see two clocks on a shelf keep the same time, but that doesn't mean that one of them is causing another. The whole question of whether you can learn about causes and effects from observation is difficult. It's embodied in the statistician's dictum that correlation does not mean causation. And I want to take a moment for the philosophy of Immanuel Kant. Kant turned that question around. And what he said was that our experiences are made up of two parts. There's what's in our heads, there's what preconceptions, ways of thinking that we have, what he called the a priori, and there's what we see in the world. And he said one of the things that is in our heads, one of the a priori ways of thinking, is the idea of a cause and an effect. Every cause has an effect and every effect has a cause. And if you look at how deeply that is embedded in much of the educational research that you will look at, you will find that when we see a group of people who in principle look as though they're all similar, but they do different things, then we say to ourselves, there must be a cause. There's the effect. People do different things. People who look similar do different things. That's the effect. There must be a cause for it. Let's look for the cause. So there's a group of people. They all look the same, but they turn out to be doing different things later in their careers. So they're secondary school students, and some of them stay on at school and some of them leave. What's the cause? What's causing those people to leave school early? What are the risk factors? What can we identify in their background that makes them susceptible to leaving soon? Or here's a group of children, some of them study sciences, some of them study arts. Can we identify what makes them different? What makes the scientists study science and the artists study arts? What's the cause? What's the difference in between that group? Or here's a group of teachers, young teachers just qualified. Some of them are going to stay on in teaching. They're going to carry on their teaching careers until they retire. And some of them are going to leave after 2 or 3 years of teaching. They're going to leave the profession. Can we identify what the difference is? And in every case, we're looking at a group of people who superficially look the same, but who turn out to be doing something different. And we're looking in the research, what's the cause that produces this effect? This is a very, very common way of looking at educational research. And if you read through the papers you're dealing with, if you look at the research that you're interested in, you'll find that reasoning coming up again and again, time and again. Now, I've introduced the idea of Kant that cause and effect is one of the ways in which we organise our experiences. We use the idea of a cause and effect, and we're predisposed to, if something goes wrong today, I'm looking for the misalignment of the stars, the malice on the part of people around me, the good-willing wishes of somebody who I bumped into on the street, some piece of good fortune. I'm looking all the time, we're looking for causes and effects. And that seems to be embedded in the way we think and the way that we make sense of our experiences. Now, that was Kant suggested that it's part of the way human beings are to think in terms of causes and effects. Now, Kant has been proven to be wrong in lots of different things. most crucially, his philosophy was rooted in the science of Isaac Newton, and so when relativity came along, when Einstein presented relativity to the world, we had to rethink Kant's way of looking at the world, and in particular, the idea of a cause and effect implies a kind of time sequence through history, and relativity suggests there's not a fixed sequence. We can't necessarily say that this thing always comes after that thing. So there are problems with cause and effect. And later philosophers like Michael Friedman suggested that Kant's argument was in two parts. The first part is something like cause and effect, the a priori is part of our way of thinking, and Kant also argued that it was the same for all people for all time. And Friedman suggests that it's not the same for all people for all time. The idea of a cause and effect can evolve, our way of viewing the world can evolve. And so I want to suggest to you that Kant is both right and wrong. We look at educational research, look at it for yourself, and you'll see a huge amount of it assumes the idea of a cause and effect. So Kant is right in saying many people, most people, almost all people use the idea of a cause and effect to structure their thinking, to structure their reasoning about the world. But it could be otherwise. The times may have changed, new ideas may be necessary, and we may need new ideas that replace the idea of a traditional cause and effect in order to make sense of the world as we now know it. So, but you look how often the notion of a cause and effect, you watch CSI, every contact leaves a trace. The idea of cause and effect is right through our culture. But could it be otherwise? And I'm arguing, yes, it could be otherwise. Well, it would be sort of more convincing if I could give you an example where it is otherwise. I could give you an example where we can think about human interactions not in terms of cause and effect. And that's what I'm going to do now. I'm going to try and do now to get you to think about human actions that cannot be described in terms of cause and effect. I want you to think about this group of 18 people over here. And I'm going to ask these 18 people in 9 pairs to play a game called rock, paper, scissors. I'm sure you're familiar with rock, paper, scissors. I'm going to blow a whistle, ring a bell, give some signal, count to 3, and ask each of those people to make a shape with their hand that represents a rock, paper, or scissors. So that's what they're going to do: rock, paper, scissors. And if they, depending on what the outcome is of each of those sequences in turn, they're going to win or lose. Rock is going to be beaten by paper but will beat scissors. Paper will beat rock but will lose to scissors, and scissors will lose to rock but win to paper. And if the two people choose the same things, the same symbol, rock, paper or scissors, then it's a draw and nobody wins. So we're going to blow the whistle, and you know what's going to happen. You know what's going to happen. Of those 18 people, 6 of them are going to go rock, 6 of them are going to go paper, and 6 of them are going to go scissors. And they're going to win or lose accordingly, according to what their opponent is doing, how they're paired up with their opponents. But 6 of them are going to be scissors people, 6 of them are going to be paper people, 6 of them are going to be stone people. And you would think me mad if I went out now and looked for the genes. I'm looking for the scissors gene. What makes these 6 people scissors people? What makes these 6 people stone people? Where is the trauma in these children's background that makes them paper people? You'd think I was mad if I did that. If I was looking for the cause of why somebody was doing scissors, why somebody was doing paper, somebody was doing something, you'd say, no, you've misunderstood the situation entirely. The setup means that at random they're going to pick scissors, paper or stone, rock, paper, scissors, because the whole point of the game is to fool your opponent, not to be predictable. But we know, because it's symmetrical, that a third of them will do one thing, a third of them will do the second thing, and a third of them will do the third thing. But if we blow the whistle again, if we say, right, let's play the game again, the second time round, a third of them roughly will do rock, a third of them will do paper, a third of them will do scissors, but it'll be a different third. And we'll do it again a third time, and still a third will do rock, a third will do paper, a third will do scissors, but it will be a different third. We won't be able to predict what an individual is doing, but we will know in general on the pattern. We'll not be looking for what is it that makes a scissors paper person? What is it that makes a rock person? No. Cause and effect is not a relevant way of understanding this experience. And what I'm going to do next is I want to have a look at analysing this rather more closely. This is a zero-sum game. If one person wins, the other person loses. So in total, the winnings equal the losses. So it's a zero-sum game. It's got a lot of people in it, and there are 3 choices that each person has to make, and the outcome depends on the choices that they make. So let's consider a pair of players, A and B. If A and B both play the same thing, then it's a draw. Neither of them wins, neither of them loses. I'm going to put in the winnings of B. B wins nothing if it's a draw. If B plays paper and A plays rock, paper beats rock, so B gains 1. But if B plays scissors and A plays rock, then scissors loses, and that's a loss of 1. Quite simply, if B wins 1, A loses 1. If B loses 1, A wins 1. We don't need to fill them both into the grid like before. And so if B plays rock and A plays paper, paper wins, so that's a loss for B. And if B plays scissors and A plays paper, that's a win for B. And if B plays rock and A plays scissors, that's a win for B. And if B plays paper and A plays scissors, that's a loss for B. And this is a payoff matrix, so that when we've got a combination of whatever B plays of these 3 options, whatever A plays of those 3 options, we can see what the outcome is. In this case, in terms of the outcome for B, a 1 is a win, a -1 is a loss, and a 0 is a draw. And this is the payoff matrix that represents this situation, and the if you the player settles on playing one of those options all of the time, then they're going to lose because their opponent will be able to beat them because they can anticipate. What I want to say about this is I'm interested in game theory because it captures something that to me is very important about the way humans behave, that in large numbers they're predictable. You get 18 people is a fairly large number. 6 of them will be doing rock, 6 of them doing papers, 6 of them doing scissors. But the individuals are unpredictable. And that's actually not dissimilar to many situations that I see in life that I want to explain. A supermarket manager needs to know how many pints of milk, loaves of bread, cans of soda, whatever it is, they need to know how many are going to be sold in a day. They don't need to know which people are coming in order to work out what their stock needs to be. They don't need to know that Mr. Smith or Mrs. Brown is going to want an extra pint of milk this week. No, they want to know the behaviour in large numbers. Similarly, I know if I go out into the streets of London tomorrow morning at 8 o'clock, I'm going to find traffic jams. I know where the traffic jams will be. I know where the traffic gets congested at 8 o'clock on a Tuesday morning. I don't need to know who's going to be in the traffic jam in order to understand what traffic lights do, what roundabouts do, what traffic signals do. I don't need to know all of those things in order to know where the traffic jams are going to be. If one person doesn't go to work tomorrow because it's a sunny day, or because they've got flu, or whatever reason an individual might have for not being in that traffic jam, doesn't affect the traffic jam. There's going to be a traffic jam because en masse, in large numbers, the behaviour of people is predictable. It's unpredictable at the level of the individual. And that seems to me to be an important feature of human activity, which we might well bear in mind. But the other thing that is important is that a policymaker, a person who's preparing policy, the policymaker doesn't need to know about individuals. They need to know about the proportion of people who are going to be making a particular choice. They don't need to know what is B going to play this time. They simply need to know a third of the people are going to be playing paper, a third rock, a third scissors. Notice that when we were looking at cause and effect, if you knew the cause and the effect, you knew, or you aimed to find out, which people, which individuals that cause applied to and what the effect was going to be. That's not necessary. We don't need to think in terms of cause and effect in order to be effective policymakers.